once again to our science tutorial. We are still on physics mail, which is the physics aspect of science tutorial. We started looking at revision series that will help us prepare students that will be writing the WASI exam and the UTMB and also the NECO exams. So yesterday we started looking at the concept of measurement, and we were able to look at the three important terms that are associated with measurement in physics. We looked at quantity, we looked at dimension, and then units. It is very important that if you are preparing for SSC, or even if you are not preparing for SSC, you just join this program because it will help you in the study of physics. We are not going to limit this to physics alone because we'll also be having revision series on mathematics, chemistry, and also biology to make sure that our science students, they excel in their exams. So we are going to continue from where we start on concept of measurement. We have defined quantity. We talked about fundamental quantities and derived quantities. We also defined dimension and units. The first video dealt with that, and we looked at the table of the fundamental quantity, their dimensions, and also their units. So today we are going to look at how are we going to obtain the dimension and units of derived quantities. So we have looked at the dimensions and the units of fundamental quantities. So our business today is how are we going to look at the how are we going to obtain the dimension and units of derived quantities. So dimension and units, dimensions and units of derived quantities. Dimension and units of derived quantities. Now, when we are given a derived quantity, remember we said that a derived quantity is a quantity that depends on two or more quantities in order to obtain its dimension and also the unit. So how do we obtain the dimension and units of a derived quantity? We're going to look at the steps that we are going to take before we now cite some examples on that. So begin this way. To obtain the dimension and units of derived quantities, obtain the dimension and units of derived quantities, there are steps that we need to take. So what are these steps? So we say to obtain the dimension and units of a derived quantity, we take these steps. We take these steps. So what are the steps? Number one, take note of the quantity and write a suitable formula for calculating the quantity to ensure that the quantity is the subject of the formula. Okay. Express all the quantities in terms of the dimensions of the fundamental quantity. In terms of the fundamental quantity, then What next should we do? What next should we do? Then simplify. Simplify to obtain the dimension. And replace the dimensions with their appropriate units. To obtain the units. So when we want to calculate, or obtain the dimension and the units of a derived quantity, what are we going to do? We just need to take these 4 steps, then we'll be able to obtain the dimension and units of derived quantity. So the steps are as follows. Take note of the quantity and write the suitable formula for calculating the quantity. That's the first thing we do. Then we ensure that the quantity is the subject of the word, of the formula. That's the suitable formula you have written. Then the next thing is to do what? Express all the quantities in terms of the word, dimensions of the fundamental word, quantities. Then finally we simplify to obtain the dimension, and then replace the dimensions with their appropriate unit to obtain the word, the unit. Now before we start taking examples, there is need for us to actually look at one more important thing that will enable us to take some examples. Now there are some quantities that have the same dimension with length. So I want to say this. Note, width, breadth, height, depth, thickness, displacement, distance, extension, circumference, perimeter, wavelength. Okay, let me just add, and amplitude. All have the same dimension and unit as length. So the dimension of all these quantities that I've just mentioned are the same as the dimension of length. So width has the same dimension as length. You remember that when we looked at the fundamental quantities, the table that we consider, we discovered that the dimension of length is actually L. So width, the dimension of width is L, dimension of breadth is L, height L, distance L, displacement L, wavelength that we consider in wave motion is L, circumference of a circle, perimeter of a shape, their dimension is also L, amplitude L, distance we have said that, depth, height, they all have the same dimension with L. So for example, when we have, I want to find the dimension and the unit of speed. We know that speed is distance over time. Distance over time, that's the rate of change of distance, that's speed. So that distance there, the dimension that we are going to assign to the distance will also be L. So it's important that you take note of this. Not when we now see distance, somebody will now be thinking, oh, what is going to be the dimension of distance? Distance, displacement, and all other quantities that I've just listed, they have the same dimension as well as length. All right, let's look at now some examples. We're going to look at some quantities and their dimension. So let's just cite examples. I want to find the dimension and the units of some quantity, some derived quantity. Let me start with the simplest one. Let's talk about area. Area. We usually say area of a rectangle, area of a shape, maybe rectangle or square, and so on and so forth, or even a circle. I did not add radius here. Radius also have the same dimension with length, the same thing with diameter. So all the quantities that are related to length, they will have the same dimension with length, and these are the quantities. Diameter is also there, the same thing with radius. So let's say that we are dealing with our area. We know that area is length times length, or length times width. For a rectangle, length times breadth. Now, we look at this again. Move on. We are following these steps. They say to obtain this, take note of the quantity. The quantity is area, and write a suitable formula for calculating the quantity. Now, area is length times width. We have actually written the suitable formula. The quantity that we want to find its dimension is area. Okay, now they say ensure that the quantity is the subject of the formula. Okay, this quantity, area now, is the subject of formula. It has been expressed in terms of length and width. So we are still following our steps. Now, express all the quantities in terms of the dimensions of the fundamental quantity. So we are going to express these two quantities in terms of the dimensions of the fundamental quantity. Now, length. What's the dimension of length? We know is L, so it's a fundamental quantity. We have also, by the virtue of what we have written here, the dimension of width is also what? Length. So, when we have done that, that's what we have done now. They say simplify to obtain the dimension. Let's simplify this. Length times length will give us length squared. Now, the dimension of area, this is the dimension now. That's the dimension of area. Now, what will be the unit now? So, simplify to obtain the dimension. We have obtained the dimension. They say replace the dimensions with their appropriate word, unit, to obtain the word unit. So, what's the unit of length? In the table, the SI unit of length is meter. So, we replace meter, but this length has power of 2, so meter squared. Now, this is the unit of area. That's why after calculating areas of shape, we usually assign meter square to the result. That's to the numerical result that we obtain. Or if maybe they want it to be in centimeter, it's going to be in centimeter square or kilometer square. So that's the dimension of area, and that's the word unit of area. That's simple, very simple. Now we need to let's keep our steps until I've mastered it. So we need to clear everything. Remember, it is still revision series. Let's keep our steps. Let's pick another quantity, another simple quantity. Let's look at volume now. Volume. You can say that volume is length times breadth times height. That's volume. If we are following our steps, we are told to take note of the quantity and write a suitable formula for calculating the quantity. So volume is this. Now, it means that it will be difficult for someone to actually obtain the dimension and unit of a derived quantity if you don't know the formula for calculating the quantity. So if you will calculate, or if you are going to obtain the dimension and unit of a derived quantity, it's important that you do what? You know the formula for calculating that particular derived quantity, or the formula where we can find that derived quantity. Because in some cases, a quantity may not be the subject of formula. It may be inside another quantity. So we need to now make it the subject of formula following our steps. But here, volume is length times breadth times height. That's the first thing we are asked to do. Then the next thing we are asked to do is to ensure that the quantity is the subject of formula. Here, volume is actually the subject. Then next, express all the quantities in terms of the dimensions of the fundamental quantity. So length is still L, breadth is still L, height is still L. Simplify. That's the next step. Length times length times length give us length cube. This is the dimension of volume. And then in terms of units now, we're going to have length is measured in meter. So this is going to be what? Meter cube. Meter cube. Is this beautiful? Very beautiful. Very, very beautiful. Okay, so the dimension of volume is length raised to power 3. That's length cube. Why the unit is meter cube. That's why when we calculate volumes of shape, volume of cylinder, volume of cone, volume of a cuboid, volume of a sphere, volume of a pyramid, once we calculate volume, at the end of the day, we usually insert the unit, meter cube or centimeter cube. That's how we obtain that particular unit. Because I don't want to clean this, because I want us to be looking at the steps until it has become a part of you. We'll just take care of this and then we'll now clean the steps so that we'll have space. I believe you are taking notes of everything we are doing. Just write them down because it will help you. We are still on examples. I have to keep these steps. Let's be looking at them. Okay, let's quickly look at the third example. I talk about density. Density. Who will remind me the formula of density? Oh, so sorry, I don't have a physical class, but you can remind me from your residence. I will hear it anyway in the spirit. Don't mind me. So density, what's the formula for density? Density is mass of a substance over the word volume of that substance. That's density. That's density. So we have written that the formula for calculating it. Ensure that the quantity is the subject of formula. Here, density is the subject of this formula. Okay? Then we go on. Say, express all the quantities in terms of the dimensions of the fundamental word quantities. Okay? Mass. What's the dimension of mass? We go to our table. Mass is capital M. Dimension of volume. We just obtained volume. What's the dimension? Length raised to power what? 3. So volume is length raised to power 3. Okay? So it means that this is the dimension. We can write it in alternative way. Mass per length cube. This per length cube. So I can write it mass per length cube. Or if I apply the principle of mathematics, the principle of indices, I can write it in another form by saying mass per length cube. This negative sign, you remember the fourth law of indices, when you have 1 over L raised to power 3 is L raised to power minus 3. A negative index is the same thing as finding reciprocal, then removing the negative power. That's a negative sign in the power. So if I have A raised to power M, same thing as 1 over A raised to power M. So when we now have M over, okay, let me use M before people would think that the N or S here. Before someone would think that the M is this M. So we have this. This is the same thing as saying, this is something as saying M times 1 over L raised to power 3. That's what it means. Because when M multiplies 1, it is still M. So we have M over L raised to power 3. So we did not change anything here. So if we now go further, this is equivalent. So having M L raised to power minus 3, because this is a reciprocal. When it comes up here, you have this. So generally, A raised to power minus X is 1 over A raised to power X. So you can move like this. You can also go back in this one. So when it is like this, I can write it like this, following the law of what? Indices. That's how we obtain that. So this is the dimension. Take note. This is the dimension. I don't have space to write it down, but this is the dimension of what? Of density. That's the dimension of density. This. Then we can actually put down the units. What will be the unit of density now? This one is the dimension. That's dimension. So what will be the unit? We continue here. What's the unit of mass? Mass is measured in kilogram by SI unit. And length cube, this is going to be meter cube. Or I can write it as kilogram per meter cube in that way. So that's why anytime we have density, we have this. We have this. All right. We have to take one more, then I will give you some We'll go on break. When we return, we are going to solve more problems on dimension. We are going to obtain more quantities, the dimensions of more quantities. Now, I believe that you have taken notes of these particular steps. They are part of you and you have written it down. So I think I still have it with me, even without looking at them. So we can quickly, you have mastered it, you may not even need the steps again. Maybe it's now part of you, may not need to refer to them again in order to do justice to this. So this is the unit of dimension of density now. Okay, let's say that should be the question number 4 now. Which quantity are we going to pick? Okay, let's pick our beautiful speed. We have said that speed, the formula is distance over what? Over time. Beautiful enough, distance over time. Distance, we have said that distance has the same unit and dimension as what? As length. So we have written the formula. The speed is the subject of formula, still on our steps. Now we have to write everything here in terms of the word fundamental word quantity. So we have to express distance in terms of fundamental quantity, and then time in terms of fundamental quantity, that's their dimension. Distance, the dimension is L. We know why it is L. We have said that distance has the same dimension with length. So time, we know the dimension is T. It's in your table. If you did not watch the first video on this concept of measurement, then it becomes very important that you go through that video so that you can actually understand how we obtain these dimensions of the fundamental quantity. Then we simplify. You know, I can write this as length per time. I can write it as length per time. Length per time or length per time. Okay, beautiful. This is now the dimension of speed. Dimension of speed. You can still leave it like this, length over time, we understand. Then length over time, we have explained the fourth law of indices. 1 over t is t raised to power minus 1. 1 over t squared is t raised to power minus 2, and so on and so forth. So we declare this. What will be the unit? Quickly, unit of length is meter, unit of time is second. So meter per second, that's the unit of speed. Then meter per second. So the unit of speed is meter per second. Okay, I'm tempted to give one more. Okay, let's just look at one more. Then we'll be done. So we have velocity. Velocity is displacement over time. That's our wonderful velocity. The beautiful velocity, you know. You must have heard about velocity in your study of physics. So what is exactly the dimension and the unit of velocity? Now velocity is displacement over what? Over time. Now we have written the formula. The subject of formula is the quantity of interest, still on our steps. Now we say, let's replace this by the dimension of the fundamental quantity. So what's the dimension of displacement is L. Dimension of time is T. Look at it here. Displacement is here as one of the quantities that have the same dimension with what do you call it, with length. That's why we have to mention this before someone will become confused. Some people may even say that, oh, displacement is now d over t. Then we have d per t. No, it's length per time. It's length per time. So we can still condense this to write it like this, or length per time. Sorry, per time. So this is the dimension. Then the unit now will be meter per second or meter per second. Meter per second. Now you will notice that speed and velocity, they have the same dimension and they have the same unit, but they are not the same quantity. Yeah. So it's possible that you can have two different quantities that we have the same word dimension and the same word unit. They are bound. By the time we now look at more examples on dimensions and units, you will see that there are so many quantities that have the same dimension and the same word unit. Speed and velocity are typical examples. Now, the difference here is that speed is a scalar quantity and velocity is what? A vector quantity. By the time we look at vectors and scalar, we will remind ourselves what we mean by scalar quantity and vector quantity. We say that a scalar quantity has only size or magnitude, but no what? Direction. But a vector quantity must have size and also what? Direction. So a vector quantity has size or magnitude as well as what? Direction. So to fully define a vector quantity like velocity, we'll talk about the size of that quantity and also talk about its direction. To fully define a scalar quantity like speed, we only talk about its size because it doesn't have a direction. All right. I'm going to give a simple question that will return to look at the answers to those questions. So quickly. Let's say this quick quiz, very quick quiz. It's because it's going to be quick. Find the dimension and units of acceleration, force, and momentum, given that acceleration is velocity change over time, to force is mass times acceleration, and 3, momentum is mass times velocity. Okay, just these 3. And when we come back, we're going to look at them, obtain their units, and then we look at some other derived quantities. But before I go, remember, not all the quantities that we know, not all of them have what? Dimension, and not all of them have units. There are some quantities without units. Such quantities, we call them dimensionless what? Quantities. We are going to see a few of them, things like tensile strain, things like mechanical advantage, things like velocity ratio. They don't have what? They don't have units, they don't have dimensions. So we refer to them as dimensionless quantities. I know that you are actually enjoying our revision class on this subject physics. We are still on physics mail. It's an aspect of science tutorial. Continue to enjoy this class. We don't want you to have F9. Oh, that would be terrible, because F9 will not take you anywhere. Even E8, it will be useless. Even D7 will also be useless. If you are in C6, you are actually dwelling at a boundary. It is very dangerous. We want you to prepare very well so that you have A's and B's in your exam. Yes, A's and B's. We want you to be an excellent student. And that's why we are bringing this program to you, to make sure that you are fully prepared to deal with any question that you're going to see in your UTME and also in your WASI or NECO SSC. Till we come your way next time, continue to enjoy the meal, the delicious meal we have prepared for you in physics. Get your physics fork, get your physics spoon, get all the physics cutleries, and begin to enjoy your food. Thank you and God bless you.